Hey there! Today we're going to talk about what a digital signature is and what it means to digitally sign an electronic document, for example, an SSL certificate, which we discussed in the previous video. There are two things you should understand before we can move on. First is hash functions, and second is asymmetric pairs of encryption keys. It may sound scary, but the concepts are very simple, so bear with me. Let's start with the hash functions. If you have some data, and you apply a hash function to the data, the outcome of the function will be a new string of a fixed length called digest. And as long as you or anybody else apply the same hash function to the same data, it always produces the same outcome. At the same time, when you or anybody else apply the hash function to a different data, the outcome will be a different string of the same length. Now let's get to the asymmetric pair of encryption keys. As you may already know from my other videos, asymmetric pair of encryption keys is a public key and a private key. The public key is something that can be publicly distributed and available to anybody, hence the name public, while the private key must be kept in secret by the owner and hence the name private. The main thing about these keys is that if some data is encrypted by the public key, it can only be decrypted by the private key from the pair. In order for the digital signature to work, the opposite should also be true. If data is encrypted by the private key, it can only be decrypted by the public key from that pair. Now we can actually get to the digital signature. Let's assume there is John, who has an electronic document which should be digitally signed by Bob. In order for Bob to be able to sign the document, he should own a pair of asymmetric encryption keys and know how to use them to encrypt data. He also should know how to apply a hash function to data. In reality, these operations are taken care of by a special software, but to better understand the process, we will assume Bob just does all required operations by his own hands. The process would start with John sending the unsigned document to Bob. Bob would apply the hash function to the document and get the outcome, the document digest. He would also preserve the original document. Then, Bob would encrypt the document digest with his private key. The received data would be the actual digital signature of that document. Bob would add the digital signature to the original document and then send the digitally signed document back to John. Now John has the document with the digital signature, and the signature could be used to reliably prove that the document was signed by Bob and not somebody else, and that Bob signed exactly that document. Let's see how the signature can be used to prove these things. Imagine that John gives that signed document to somebody else, for example Sarah, and claims that it was signed by Bob. Also imagine that Sarah may not necessarily trust John by word, and she would want to validate the digital signature to make sure that it was really Bob who signed the document and that Bob actually signed exactly that document. That validation would require Sarah to have Bob's public key. Remember that public key is meant to be shared with anybody, so Bob should not have any problem sharing it with Sarah. She also would need to know how to work with the hash functions. Of course, signature validation is also performed by the special software, and in here we are just pretending that Sarah does it manually to better understand how this all works. So, first, Sarah needs to separate the document and the signature from each other. Second, she needs to apply the hash function to the document without signature, similarly how Bob did when he was signing the document. If it is the same document as Bob signed, she will get the very same document digest as he did. On the next step, Sarah needs to focus on the signature. Remember that it is essentially the document digest which Bob encrypted with his private key when he was signing the document. Now she should try to decrypt it with Bob's public key and compare the result with the document digest she gotten in the previous step. If the digests are the same, it means that the signature was created using Bob's private key, which means it was Bob who signed the document. It also means that it is the same document as Bob signed, because otherwise hash function would generate a different digest on the previous step. Now, let's get a little bit more technical and see how the John, Bob, Sarah, soap opera can be mapped to the SSL certificate validation process during establishing HTTPS connection, which we discussed in the previous video. If you think about the roles, John would be the server, Bob would be the trusted organization or so-called certificate authority, or simply CA, and Sarah would be the client. Clients usually have pre-installed public keys of all the organizations they trust, and in our example it would be Bob's, or trusted organization's, public key. The server, before it actually starts serving any request, asks a trusted organization to verify and vouch for it. Trusted organization verifies the server information, creates the SSL certificate with the server's public key and other information in it, and puts its digital signature. Finally, when client establishes HTTPS connection to the server, it verifies the certificate. It finds out from the certificate itself who is the issuer and uses pre-installed public key of that issuer to validate the SSL certificate and its digital signature. This way, client makes sure that the information in the certificate was not forged and that the signature actually belongs to a trusted organization. That's all I have for today. As always, I hope that video helped you, and if so, press like, subscribe, and I'm looking forward to seeing you soon again.